So once you have some map files saved and you want to load it into the game, it's a matter of parsing it if you're using something like XML or just your plain text. If you've saved your maps in XML format, then say, for example, C# in the .NET library has some really nice libraries for parsing that. If you're using C++, you'll probably want to find a library. You don't really want to write your own XML parser just because it's reinventing the wheel. Just because it's reinventing the wheel and all of that. So if you've stored your map in some sort of plain text, then you should just use some standard ifstream functionality. You could also look into writing something to serialize everything, so that might help with the map saving side and map loading side. So here's an example of a map that I made, and it's not really that attractive. This is actually the original Rarinth map, and I took the old file and I wrote something to convert it into this format. So as you can see, the first few things it's parsing is the width, height, and depth. And then everything has like X, Y, Z. The first one is just the tile index, which is pretty much ignored, but then it has X, Y, Z, image code, solid, no, stuff like that. And then I have a map loader, and it's not very beautiful. It's a little bit, I don't really like my functions to be this long, but I was trying to get this done before a deadline. So here we're just loading with ifstream, the map file. We have a new level object, and then I create a buffer string. Then we have map dimensions. Those are loaded in and stored. Then we set the level dimensions. We have some data that's going to be loaded in each time. So while the map file is going through the entire, or while the buffer is going through the entire map file, this is basically kind of just my lazy parsing. Because C++ automatically parses via white space, I've kind of taken advantage of that here. So basically every time it pulls something into the buffer, it's going to be one of these letters or a number. So what I'm counting on is that every time it's going to grab a letter, and when it grabs a letter or a word, it's going to immediately grab a integer or whatever it needs. So see, if the buffer read an X, then we're going to grab in another thing, and it's going to be our X coordinate. If it's Y, grab the Y coordinate. If it's the image code, we're going to grab the image code, tile code. If it's solid, we're going to grab whether it's solid into, and these are the Boolean and an integer. And then when it hits the end flag, it says, okay, we're going to create a new tile. We're binding the tile sheet image. We're setting the coordinates, setting the dimensions, setting whether it's solid, finding the thing on the tile sheet, and then we're also into the new level, push onto the vector of tiles, push back the tile. So that's my map loading code for this type of map.
So say that we have a map that's pretty big. You're not going to be able to show the entire thing on the screen at one time. We want the screen to stay centered on the character, so as the player moves around, the screen's draw region will be offset. The question is, how do we know what this offset is? Well, look at it this way. If the screen is always centered on the player, then the left edge of the screen is always half a screen width away from the player. Also, since the player's XY coordinates are with respect to its top left corner, we can get the player's center by adding the width or the height divided by 2. To get the X offset, you'll take the player's X coordinate plus half of its width to get the center point. Then you subtract half the screen width. The Y coordinate is pretty much just the same, except dealing with the height. Okay, we have an offset, but what do we do with it to get the graphics to draw properly? Say we have a tree at 192, 192. If the screen offset is just at 0, we can draw everything normally. The tree goes at 192, 192 with respect to the screen's origin and the map origin. However, if the offset isn't at 0, then the tree looks more like it's 2 tiles over and half a tile down when we're looking at just what is on the screen. When we draw the tree, the map, characters, etc., we will have to subtract its current position by the screen offsets. The only thing you wouldn't do this for would be HUD data, stuff that is always on the screen like the player's health bar and stuff. So if we ignore the rest of the map and look at only what's on screen, then 128.32 are the correct coordinates, even though the tree has different coordinates on the map itself.
And really, when it comes to drawing your maps efficiently, you'd basically use the same sort of math to see if a tile is on the screen. If it's outside of the draw region, or what's shown on the screen, then you just don't draw it. If you're drawing everything, even what's not on screen, your program is going to start slowing down really fast. And another tip is to use pointers and references, because copying objects is slow. So if you happen to be doing some sort of copy with your draws or something like that, then things are just going to slow down really fast. So that's really all I have to say about map files. If you're still having trouble, it really helps to sit down with a piece of paper and a pencil and calculator. Try to sketch out the parameters. I've solved a lot of conceptual problems by just trying to come up with an example of what I want to do with some sample data, some sample numbers, and trying to figure out an equation or pattern and whatnot. So still, if you have questions, post them in the comments or email me or something like that.
Also, if you like the videos I make, and for some crazy reason you want to support me with monies, my website has some dandy buttons for donating or buying t-shirts. I'm trying to make some t-shirts that aren't just related to Musader games, nerdy shirts, cute shirts, random things, so I'll be updating the store a bit more now as I get different ideas. And I just really hate advertisements that obscure videos or play at the beginning, so I'm never gonna do that. So yeah, t-shirts.